Hi everyone, my name is Marcela Bonel. I'm a cloud software engineer working at Intel in Mexico, and today I will present you a tutorial about how to use Shade SDK to interact with the OpenStack storage services Swift and Cinder. So before I start coding, let me explain a little bit more about these projects. The OpenStack object storage project is called Swift, and Swift allows you to have a redundant and scalable data storage where you can retrieve, leverage, and update large amounts of static data. And everything is managed by the Swift API. The two resources that you will find there are objects and containers. Objects refers to data, and data could be images, documents, everything that you need to have in everything that you need in your cloud, something static. And containers are namespace that are used to group objects. So you can place many objects inside a container and have a lot of containers in your cloud. So Swift is it's an optional project for OpenStack. So before start coding, validates that your cloud has Swift running. Okay, so let's start with code. As already mentioned, we will be using the Shade SDK for OpenStack, which is a Python library, very easy to use and with very clear functions. Okay, and so starting with the Swift code, first we will start to import the Shade library. Then we need to specify our cloud. For this exercise, I'm using the OSIC cloud. For the ones that don't know about OSIC, OSIC means OpenStack Innovation Center. So this is an effort between Intel and Rackspace to have a lot of developers working on improved OpenStack. So they have a cluster for the community. It's open for everyone, where you can request access to develop and test application. This is the form to request access to the OSIC cluster. And basically with this cluster, if they approve your request, you need to share with the community your findings, public the results for the applications, because at the end this is for the community. So when you request access, you need to specify the purpose of your project, the OpenStack project that we will use by your app, the specification, quota, and then a board will review all the submissions, and they will decide if they can give you access or not. So I'm using this community cloud OSIC for interact with Shade and Swift and Cinder. Okay, so let's start coding. Okay, starting with Swift. First, we will create a container. Remember, a container is a place where you can group your objects. So I will create a container which name is my pets, and the shape function is create container. Very easy. You only need to specify the name of the container. Then I'm using the list container functions where I will print all the containers in my cloud. So this is my cloud, the ASIC. Okay, so as you can see, I don't have any container. So I will run my script to create my first container. And here we go. We list them. We can see here we have my pets ready. So let's validate in the cloud. Yes, I have my pets container ready. No objects, no size. So next, let's start uploading objects to Swift. Now, I have a dictionary where I'm specifying the names of some images that I have in my file, in my local file system. I have two images: my pets, Euler the Pomeranian, and an amazing goat. So I want these resources available for everybody in my cloud. So I need to specify the name of the objects and the location in my file system. So the shape instructions to create objects is create object, and you only need to specify the name of the container, that will be my pets, the name of the object, and the file path. And then once they are created, I will list the objects that are inside my pets container. So create object and list object, very straightforward instructions with shape. Thanks, shape. So let's update these images. I will run the script. They are creating, and now here we go. We have the amazing goat and Euler the Pomeranian here. So let's see how looks our container. Yeah, we have these two objects. I can download one of them to validate that it's not corrupted. And yeah, we have Euler in the cloud. So this is the way that you can interact with Swift API through Shape to create containers on objects. So also you can use Shape, have more functionality about objects and management for containers. So now with this code, I will delete all the objects inside my pets container. So the instruction is delete object. You need to specify the container name and the name of the object. And once that the container is empty, you can delete it with the delete container function, specifying only the name. So very, very straightforward. I will be printing goodbye and the name of the object when every time that Swift deletes an object in my cloud. So let's run this, and it's deleting the goat and the Pomeranian. So no more Pomeranians or goats, no more pets in my cloud. Yeah. Okay, they disappear. So very simple instructions to interact with Swift. Remember, with Swift you can upload them, update it, create many objects with organized by containers as your application or needs. You can put images, you can put documents, any static file that you need in your application. And Swift manage everything for you. I mean, you don't need to care about the low-level details for how the objects are replicated, the scalability. You only need to put the objects there, okay? So, very easy. And now, let's continue with block storage. So the block storage project in OpenStack is called Cinder. And by default, all the data in the OpenStack instances are stored on ephemeral disk. And this means that when you terminate an instance, all the data is stored in that instance will disappear too. Ephemeral disks are not persistent data. See, if you lose your instance, you will lose your data. So here is when Cinder comes to provide block storage, persistent data resources that the OpenStack instances can consume. So with Cinder, you can create volumes. Volumes is a persistent storage resource. And you can attach a volume to a running instance in the same way that you attach a hard drive to a physical server. So you will have persistent data for your instance. And once you have an volume attached to an instance, if that instance terminates, you will keep your data safe. You will not lose it. You will be intact, and you can create another instance and attach the volume, and you will see the information without any change. So you don't have to be worried about losing instances because all your important data have to be in a volume. So the main resources that you will be interactive with Shape are the volumes and snapshots. So the volumes are the persistent storage that can be attached to a VM, and snapshots are backups that can be created to have a specific version of a volume to restore important data. So you can have different backups, different snapshots during the volume lifetime. And you can create a volume from a snapshot. So you will have your data ready and historical backups. Okay, so moves to the coding. I will use a scenario to understand more about the block storage from a developer perspective. So, for example, if you let's imagine that you have a cloud application where one of your microservices is a database instance where you have MySQL running. So what happens if you have just the MySQL instance running and something happened in that instance and you have to terminate? You will lose your database, you will lose your data, so your users will notice that and your application will fail. So with block storage, you can have a volume attached to your database instance. And for example, if you are using MySQL, you can configure MySQL to store all the data in the volume, not in the instance. So with this, you will be your data safe. And if something happened with your database instance, your cloud applications will create another instance, install MySQL, and then just to attach that volume, and your application will have the database ready for use. So your users will not notify about this problem, and you are architecting cloud applications with fault tolerance. So this is a good example of using block storage to keep your safe information away from instance, because remember, our instance are cattle, so they can be created or removed, and you don't have to care about this. You need to have all your important point of failure ready and prepared for this scenario. So okay, again, Cinder it's an optional project, so you need to validate that it's available in your cloud and that you have access to create this kind of resources. So here is where you can see the volumes and the snapshots. So here I don't have any volume or snapshot, and instances I just have one. So I will create an instance for simulate the database scenario. So first of all, let's create a volume. This is the shade function to create a volume. Create volume. You need to specify some parameters. Let's go to the documentation and basically specify size. The size is in gigabytes, the name and a description, but they are optional parameters. So I will create a volume with a gigabyte size called database, and the description is just a database volume. So let's create our first volume or first block storage with shape. Running the script, Cinder1, and okay, done. Let's validate in the ASIC cluster. Okay, yes, we have our database volume. So as you can see here, there is a attached to column, but it's empty for this volume because we haven't attached to any data, any instance. So I will create an instance for our scenario, a very simple instance for this, the volume. Okay, launching my instance, nothing special, just a simple instance that will be our database microservice. Okay, so next is to attach the volume to this instance. Okay. So the name of the instance is this volume, and the name of the volume is database. We are getting the server and the volume to send as parameter to the attach volume function. You need to specify it. Okay, I will attach a volume to this instance. This is the volume, and this will be the location of this device. Okay, let's attach this volume. Couple of seconds. Okay, done. So if I see my volume, now we have the attached to the name of the instance, and in this device. So we also can validate that in the instance details. Okay, yeah, volume is attached. Okay, we have a volume and an instance with a volume attached. So following the scenario, I will SSH this instance, and I will mount the volume to a directory in my file system. So every time that I write something in that directory, it will be stored directly to the volume. So okay. Okay, yes. Okay, I'm in the test volume instance. Okay, so now I will validate the partition table. So as you can see, this is the disk, this is the volume, this is a representation of the volume in the instance. This is the location of the volume. So now I will create in this volume, I will specify a file system. So I'm doing this with this command to prepare the volume to be able to read from my instance. So I'm preparing the file system. Okay, done. So my volume is ready for writing. Okay. And now I will create a directory in the instance to mount the volume. So in this folder is where the volume will be attached. So every time that I wrote something here will be stored in the volume. So I will mount my device, my volume in this folder. Okay, ready. So let's go to the volume. Okay, it's empty, it's ready. So imagine that here in your database instance, MySQL is writing in this folder that points right now to the volume. So every time that MySQL writes in the database, it will store in the persistent volume. So I imagine that a user is using my app and MySQL is storing everything. So I have this for another one, this 5 tables database information in my volume. So as you can see, I'm writing in this directory, but that directory is mounted in the volume, so I'm able to write them. So okay, something happened with my instance. My database instance it's not working, so my CloudAware applications will terminate it. But remember, I can recover this data because it's stored in the volume. So I will detach. Well, I will delete more. I will, just doing the scenario more real. I will delete this. I will terminate the instance. So no, my data. Don't worry, we are using block storage. So no more instance, but we have here our volume. So by now it's not attached to any instance, so we can create a snapshot just to have a backup of that moment. So I will create a snapshot with create volume snapshot function. You need to specify the volume ID, and you can put a name of the snapshot. Obviously here you need to write like the date for have an historical, right? Okay, so I will create, oh, by the way, this instance has gone, right? So I will close this. Okay, so interact, creating a snapshot with shape. Couple of seconds, okay, done. So refreshing the page. Yeah, we have our snapshot ready here. Yes, just in case we need to have backups. Okay, so obviously we have a CloudAware app, so the CloudAware app detects that I don't have that database instance running, so I need to create a new one and then attach again my volume, and so so the users we will not notify nothing because my cloud application is fault tolerant and have all the important data safe. So I will create another instance, a new instance. Okay. Okay, so I will attach the volume to this instance. Okay, so that's, but the name now is that's volume dose, that's volume 2 database, and this is again the device. Okay, so let first attach to the new database instance. I'm doing this step by step, but obviously with your CloudAware app, this have to be done in microseconds, milliseconds, so nobody will notice about this. Okay, so this volume has my volume attached. Okay, so let's SSH this new instance. Okay, and now again in this instance, obviously I don't have anything in this folder because it doesn't exist. Remember, it's a new instance, so I will create this directory because I want this directory as my entry point for store everything in my volume. Okay, I have the directory, and now I will mount my volume that it's located here in my folder, in my database folder. So it's mount. So remember the number of files that we have. Remember my SQL servers. So let's see what is there. And yeah, here we go. Or files intact. Nobody noticed about that we lost the MySQL database because everything was storage on block storage. Thanks to Cinder and Shade. I can create this more files because my application is still creating more files. Oh, yeah. Okay, so what else you can do with Shade and Cinder? Basically, now we learn how to move a volume between instances and how we can apply this knowledge and the capabilities of OpenStack projects to create our CloudAware apps. So now I will detach the volume from my instance, and at the end, yes, just like last step, I will delete our volume. So now is when all the data has gone. Will be gone because, well, I explicit delete the volume. So detach volume function and delete volume. So Shade is very straightforward with the names of the application of this function and parameters. Very easy. So now I'm detaching and deleting the I can't delete because he has snapshots, so but we can see that the first instruction, the touch was complete, but you can't delete the volume because the volume has data. Well, not has data, has snapshots. So it's like a restriction. Wait, I will delete the snapshots. Okay, and now I will delete the volume, the empty volume. Okay, done. Goodbye, database volume. Well, that's it. I hope everybody enjoy using Shade for interact with Sif and Cinder. It's very useful. You can see here more functions about how to create more and how to interact with different functions for Cinder and Swift. We only cover the basic, but still coding and go deeper with your Claraware applications and using and taking advantage of this amazing project. So thank you everybody. Bye.